Welcome to our first module on the physical installation of an HVAC cooling tower. Think of the cooling tower as the lungs of your HVAC system. If you install it incorrectly, it directly leads to catastrophic chiller failure. But get the installation right, and you secure peak efficiency and a long operational lifespan for the entire facility. In this module, we will walk through the 5 essential steps to achieve perfect airflow, 0 leaks, and 0 noise complaints. Following this precise sequence prevents system failure and guarantees maximum heat rejection capacity. Step 1 is positioning. You need to place the unit in an open space, which is typically a rooftop terrace. The system fans are designed to draw air in, but they have to overcome a baseline static pressure to function. This top-down diagram shows exactly why spacing matters. You have to maintain strict, measurable distance from louvers and surrounding walls, as well as any adjacent cooling towers. If you starve the unit of this intake air, the condenser loop cannot reject its heat, causing the whole process to stall. Proper placement ensures you are securing the actual volumetric airflow required to keep your chillers alive. Step 2 moves us from the sides of the unit to the top, where we have to manage the height of the architectural enclosures surrounding the equipment. The cardinal rule here is that the cooling tower's discharge point must sit physically higher than the top of any adjacent wall. Look at this cross-section. Warm exhaust hits the high wall and gets sucked back down into the intake vents. To fix this, either install discharge ducts or elevate the entire tower on a platform so the exhaust can safely disperse into the atmosphere. Clearing that discharge path ensures the tower will never choke on its own recycled hot air. Step 3 focuses on the physical footprint, creating maintenance access and mitigating environmental noise. You must install permanent service walkways and fixed access ladders around the entire perimeter. In this split-screen comparison, you can see a cramped unit on the left and a correct setup on the right. Notice how the correct setup places thick vibration isolation barriers directly underneath the unit's mounting points. These barriers are legally and socially required because these heavy fans often operate through the night, right next to residential zones. By installing proper isolation and access up front, you prevent future noise complaints and ensure that routine maintenance is physically possible. Step 4 is securing the water loop, which starts by connecting an uninterrupted makeup water line and performing your preliminary leak checks. If a leak drains the system and forces the cooling tower to operate in a dry mode, it can crash the entire facility. To keep water in the system, we use a component called a drift eliminator, located right at the top discharge area of the tower. The drift eliminator catches escaping water droplets mid-air, forcing them to collide against the slats and dropping them safely back down into the collection basin. This aggressive level of water management prevents sudden system crashes and saves thousands of gallons of operational water over time. Our final mechanical step is aligning the unit with the condenser water pumps. This requires establishing a state called flooded suction, which is a mandatory operating condition for any open-loop HVAC system. Look at this engineering schematic. The strict physical rule here is that the base of the cooling tower must sit at a higher elevation than the discharge flange of the pump, creating a continuous downward slope. If your piping route creates a high pressure drop between the tower and the pump, you must elevate the tower even further to compensate. Establishing true flooded suction guarantees positive water pressure, preventing the pump from pulling in air and destroying the loop mechanics. We have now successfully executed all 5 mechanical installation steps. The tower is officially verified for unrestricted airflow, cleared enclosures, complete noise isolation, and a flooded pump connection. With the mechanical side complete, the immediate next phases are electrical commissioning and recirculation testing. Make sure to subscribe to the channel so you don't miss our upcoming modules on those HVAC installation processes. A flawless mechanical installation is the ultimate foundation for a zero-downtime HVAC lifecycle.